Okay guys, I completely apologize to Group A. Group B, you already know that I apologize to you guys. I totally was a day ahead on the agenda. Anyway, Chapter 3, Section 4. These are some good formulas to write down. They will be good to know for your test. First one is for linear speed. Linear speed is V equals S over T. V is your speed, S is the distance, T is time. Another one is angular speed. So we have linear speed and we have angular speed. Angular speed, of course, deals with the angle. So theta, this is omega equals theta over T. Theta is in radians, of course. T is time, and omega, which is a fancy W, we know that I'm not creative, is representing your angular speed. Linear speed can also be written as V equals R omega. It's used depending on how your problem is set up. So two formulas for linear speed and a formula for angular speed. In example 1, suppose that point P is on a circle with a radius of 10 centimeters and ray OP is rotating with angular speed pi over 18 radians per second. We need to find the angle generated by P in 6 seconds. So looking back at those formulas that I just gave you, those equations, there's only one that has theta in it, and it's your omega equals theta over T. So we're looking for theta because we're looking for the angle. So we're going to do some algebra, and we're going to move that T away from that theta. And we're going to have theta equals omega times your time. Okay. Since pi over 18 is given to you in radians per second, that's telling you that's your angular speed. It also says rotating with angular speed. So omega is pi over 18. So theta is going to equal pi over 18, and we want to know in 6 seconds, so we're going to multiply that by 6. Our angle is then, this is going to become a 3, this will go away. Theta is going to equal pi over 3 radians. So just plugging numbers into a formula and solving. In part B, we want to find the distance traveled by P along the circle in 6 seconds. Since we are looking for distance, we also have from a couple sections back, we have the formula S equals R theta. Okay. Up here in the original problem, it told us that our radius was 10 centimeters. We found our angle in part A, so distance represented by S, as stated in the linear speed example. Distance is S, just like your arc length. So we're going to use the S equals R theta from a couple sections ago. So S is going to equal 10 times your pi over 3. So your 10 centimeters times pi over 3. We're going to leave it in radian form, so it's just S is going to equal 10 pi over 3 centimeters. And that's going to be your distance traveled by P along the circle in 6 seconds. Last but not least, we want to find the linear speed of P in centimeters per second. So we have S up here. We want to find our linear speed. And we know omega from up here in the main problem. So we're going to use that V equals R omega formula. Linear speed is represented by V. We know R, which is our radius, and we know our omega. So V is going to equal 10, which is our radius, times pi over 18. And if we go ahead and simplify, this is going to become a 5. This is going to become a 9. V is going to equal 5 pi over 9 centimeters per second. And we know it's centimeters because our radius was given to us in centimeters. Example 2. A belt runs a pulley of radius 6 centimeters. At 80 revolutions per minute. We want to find the angular speed of the pulley in radians per second. So that's part A. So we're going 80 revolutions. One revolution, one time around the circle, is going to equal 2 pi radians. And we know that 1 minute equals 60 seconds. So those are our conversions. So we need to know what omega is. If we're going 80 revolutions per minute, we're going to say 80 revs per minute. And we need to multiply that in order to get it radians per second by 2 pi radians. So we're going to do a conversion problem in 1 revolution. And then we're going to say in 1 minute, there are 60 seconds. So my minutes are going to cancel. My revolutions are going to cancel. And I'm left with radians per second. So 80 times 2 pi, or 80 times 2. And then we're going to divide that by 60. So we will have 160 pi over 60. And that's going to reduce down to 8 pi over 3 radians per second. So 8 pi over 3 radians per second. In part B, we want to find the linear speed of the belt in centimeters per second. So again, that linear speed formula of V equals R omega. Since we already have omega and we know what the radius of the pulley is, it's 6, so we're going to use the V equals R omega formula. So V is going to equal 6 times 8 pi over 3. 3 is going to go away. This is going to become a 2. Our linear speed is going to be 16 pi, which is about 50 centimeters per second. So again, you just got to look just like in physics. I know some of you are in physics. You got to look at what you have and what you need to find. One more example for this section. A satellite traveling in a circular orbit 16 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. So I need to know the distance the satellite, part A, approximate the linear speed of the satellite in kilometers per hour. So first things first, my radius is not just going to be 6,400. Technically, we have the Earth, and then we have the satellite rotating above the Earth. So this is Earth, and then we have that satellite rotating above the Earth. So technically, we have the radius of the Earth and the radius of the satellite that is traveling. So my total radius for this problem is going to be 6,400, the radius of the Earth, plus the 1,600, which is going to give me 8,000 kilometers as my radius. So now I want to find the linear speed of the satellite. So before we can find the linear speed, we need to find omega. So I have R, I need to find omega. So you got to find that angular speed. Omega, one orbit, another conversion problem, takes 2 hours. One orbit is 2 pi radians. And then with that, that is going to give us how many radians per hour. So technically, our orbits are going to cancel, and this 2 is going to cancel. So we are left with pi radians per hour. I now can find my linear speed. V equals r omega. V is going to equal 8,000 times pi. So, of course, you have 8,000 pi, which is about 25,000 kilometers per hour. So that is your linear speed. And now we want to find the distance traveled by the satellite. So we were told back at the beginning of this section that the linear speed can also be v equals s over t. S is representing the distance, t is representing time, and v is representing your linear speed. So we need to solve for s. If we solve for s, multiply both sides by t. S equals your velocity times your time, your speed times your time. With that, we want to approximate the distance the satellite travels in 4.5 hours. So we know what v is, 8,000 pi. We're going to use that number. S is going to equal 8,000 pi. And our time is going to be 4.5 hours. So we have kilometers per hour times our hours. So distance is just going to be in kilometers. So S is going to be about 110,000 kilometers. And that is it for the trig. I believe there's only 3 problems for this homework section. Review tomorrow, Friday, the 6th. And Group A will go over any questions you have on Monday. Group B, you can message me. And your test, Group B will take their test online. Group A is going to take their test in class. So just look at it on the agenda. Be sure to follow the agenda for next week. And I will be on top of the agenda and not a day ahead.